Okay, so our last material is going to be about probability models. Okay, now there are two main probability models that we are going to cover for this chapter. Okay, but they're based on a general branch of probability models called Bernoulli Trials. Okay, no, he's actually Swiss. All right, I know. So this guy here. All right, was born in the 17th century. His name is Jacob Bernoulli. His name is Jacob Bernoulli. He died in 1704, and he gave us Bernoulli Trials. Bless you. Now, believe it or not, you have been experiencing Bernoulli Trials since you were a little child. All right, without even knowing it. No, not like that movie, but I mean just like a different kind of trial. Okay, so there's really three things you're looking for, okay, to be considered Bernoulli. So the first one is that you only have two outcomes, so either a success and a failure. Okay, so if you're looking at a situation and there are more than two outcomes, it's not a Bernoulli trial. Okay? Once you check that box, then you're asking yourself, is the probability of success constant? Is it the same every time? If that's a yes, then the very last one is, are the trials independent? Now we're going to do some problems in here where they're really not independent, but I'll show you this little caveat that allows you to keep going with a Bernoulli trial even if they're not independent. But the most basic Bernoulli trial that you guys have experienced in this room is the flip of a coin. Okay, that's a Bernoulli trial, right? Success or failure, heads or tails. Constant probability of success is 50%. And they're independent. When you flip a coin, it doesn't affect the next one. Okay? That's a Bernoulli trial. Now, there's two types of Bernoulli trials that we're going to focus on. Number one is the geometric model. All right? And I want you to write next to the geometric model, in parentheses here, waiting for the first success. Waiting for the first success. Okay? So when I say geometric, you think waiting for the first success. If you see that happening, then that should tell your brain, oh, this is an example of a geometric model. Okay? So waiting for the first success. We'll do examples later where you can see an example of a geometric model. Now I want to be clear. You can't ask yourself if it's geometric until you first decide that it's a Bernoulli trial. So we're always going to first see, is this an example of a Bernoulli trial? Then we can proceed, is it a geometric model? Okay? Bless you. Bless you. Okay. Now, the other one is called the binomial model. Okay? This is number 2. And for this one, I want you to write number of successes out of trials. Number of successes out of trials. Okay, that's a binomial model example. So again, we have Bernoulli trials first. You have to decide, is this Bernoulli? And then from there, it kind of branches off. Is it geometric or is it binomial? Those two. Okay, you'll have to determine that. Now, the reason it's important to determine that is because, as you can see underneath here, we're going to have different formulas we're going to use to find these probabilities. Here is the formula we're going to use for finding the probability with a binomial model example. And here is the formula we're going to use for a geometric model. And they're very similar, but you're going to see there's one caveat when we actually do the work. Okay? Now, do you remember earlier when I said that you had to check the last thing for Bernoulli trials was to make sure that you had independent trials, all right, and that you could continue even if they weren't actually independent? Here's that little caveat from the very first thing. Okay? If you say, oh, you know what? These are not independent. But you see that your sample size is smaller than 10% of the entire population, then it's okay because those numbers are going to change so small that it's not really going to be that much of an effect. Okay? So you can always check this if it fails when you say, oh man, they're not independent. But wait, is your sample size less than 10% of the population? You okay, Drew? Okay. Okay. Are we doing okay? Okay. All right. Now, we're probably not going to get to it today, but tomorrow we will, where I'm going to show you how when you get to a point with binomial models, if they're asking you to do large numbers of trials, you get to a point where calculating it is cumbersome or it's downright not even possible. Okay? So we can actually end up checking this condition, the success-failure condition, where we're going to look at, do we expect 10 or more successes and failures? And then we can actually, instead of using the binomial model, use the normal model, which is my favorite one, and it's the first one you learned. Okay? Remember that from chapter 6 a long time ago? It was this, yep, mu, sigma. So we're not going to get to that today, but we'll get to this tomorrow. All right? Okay. So the last slide is just a summary slide, a recap of what you need to know from this chapter. So these are the three. Okay? Now again, this third one of the normal model we've already talked about, and it's really an extension of the binomial. You use the normal model as an extension of binomial once we get to too large of a number of trials where it becomes not possible anymore. All right, and as you can see, I brought in the Chromebooks, maybe today, but I have them just in case. But definitely tomorrow, we'll be doing some stuff on Desmos to calculate some things. All right? Okay, shall we try one? Great.